This video will learn about time complexity of algorithms. When the first time I heard about this term, I was like, why? Why do I need to study time complexity of every algorithm? Isn't there a best single champion algorithm for finding an element or sorting a list? And why do I need different data structures for it? Okay, suppose you want to travel from house A to house B. So you got three options. You can travel by a bicycle or by a bike, or you can just walk. Now, if you want to travel from one continent to another, you will use either a plane or a cruise ship. Or if you want to go to the moon, then you have to contact Elon Musk and you will need to buy a rocket. The point I am trying to explain here is all these machines have different cost and speed. Just because rocket is the fastest, we can't use a rocket to travel from house A to house B. I know you guys are smart, you know all these things already. But what about algorithms? We need to calculate cost and speed of each algorithm so that we can utilize them better. However, to understand how good or bad an algorithm is in general, we must know how it works over all instances. To understand the time complexity of an algorithm, we will use asymptotic notations. So there are three cases for every algorithm. First is the worst case, second one is the best case, and the last one is the average case. So we have three different notations for these cases, which you can remember by an emoji. Let's start with the worst case. We represent worst case by big O notation, and the symbol is big O, just like the emoji's face. So first we'll understand big O notation. Let's say f of n is a function that represents our algorithm. Okay guys, please don't worry about maths part. It is very easy, just stay with me. Let's plot a graph for our function. X-axis represents the input size for our algorithm and y-axis represents the rate of growth. Let's say this is the graph of our function f of n. Now what is our target? We have to find the worst case complexity. So what will you do? The solution is simple. We just need to find an upper bound, that is, we just need a function which is slightly greater than our function f of n. Let's call it as g of n function. You might say this is wrong. The function g of n is not exactly upper bound of f of n. Yes, you are correct, but we really don't care whether our algorithm sort 6 items faster. We care about greater input size. We need to understand how our algorithm performs for 1 million items. So the point from which g of n is always a bit greater than f of n is threshold for given function, and we represent it by n naught. So formally f of n is less than or equal to c into g of n. Now you will ask, what is c? So c is a constant value. So the formal definition is f of n equals big O of g of n, where c into g of n is upper bound of f of n, where n naught and c are constants. I know you might be still confused on what's going on, but we'll understand more by a practical example. Let's find an upper bound function for f of n equals n square plus 1. So we have to find a upper bound. We'll stick to the definition, that is f of n is less than or equals to c into g of n. Since our f of n is a quadratic function, we will pick g of n as quadratic function, that is n square. If you do a little bit trial and error, you will find that for c equals 2 and n is greater than equals 1, n square is upper bound for n square plus 1. I know guys that you are still confused. about how do we calculate the time complexity, but in this video we only focus on notations. In my next video I'll teach you how to calculate time complexity, all the rules and steps, but here we are only focusing on notations. Now let's see best case scenario. If you understood big O notation, then it's going to be easy. We denote the best case with omega. Again, f of n represent our algorithm. Let's plot our graph. For big O, we found an upper bound function. So for the best case, we'll found a lower bound function. So g of n is our lower bound function and n0 remains the threshold for our given function. So formally, now our definition is f of n is greater than or equal to c into g of n, where we know that c is constant. So f of n equals omega of g of n. This is how we represent the best case scenario. So for worst case we use big O, and for best case we use omega. Let's find lower bound for phi n square. We'll stick to our definition, that is lower bound f of n is greater than c into g of n. Since our f of n is quadratic, we will take g of n as a quadratic function, that is n square. So now if you observe a bit, for c equals 5 and n equals 1, this equation holds true. Now we can say that for function phi n square, its best case time complexity is n square, that is phi n square equals omega of n square. Don't worry about the maths part, just focus on the notations here. Now let's see our final case, that is average case. We denote average case with a theta. So again, f of n is our function and we have plotted the graph. Now for worst case we have used upper bound, and for the best case we have used lower bound. But now for average case, what do? For average case we try to find a function which can upper bound it and lower bound it as well. So let's say g of n is the function and c1 into g of n is lower bound for f of n, and c2 into g of n is upper bound for f of n. So formally, when c1 into g of n is less than f of n and c2 into g of n is greater than f of n, then f of n is theta of g of n. Let's understand by an example. We have to prove that n is theta of 3n plus 2. Our approach is going to be the same. We'll stick to the definition. First, we'll try to find the lower bound. So c1 into n is less than equals to 3n plus 2. So if you do a little bit trial and error, for c1 equals 1, this equation holds true for all values of n greater than equals to 1. So n is less than equals to 3n plus 1 is true. So we have found lower bound. Now the upper bound 3n plus 2 is less than equals to c2 into n. For values of c2 equals 4, this equation is true for all values of n greater than equal to 1. Now we have also found an upper bound. Now we can say that f of n is theta of g of n, that is 3n plus 2 equals theta of n. Guys, it's absolutely fine and normal if you have not understood these examples, but I hope you have understood that we denote average case by theta notation, best case by omega, and worst case by big O. That's important. Let's have some fun. Let's understand how much time complexity matters. I took this pic from the book Algorithm Design Manual by Skinner. I highly recommend this book. The first column represents the number of inputs and the first row shows the common algorithm complexities. You can see that all algorithms roughly take same time for input 10. Any algorithm whose running time is n factorial becomes useless for n greater than equals to 20. Algorithms whose running time is 2 to the power n are impractical after n is greater than 40. For quadratic time algorithms, they are good for inputs up to 10,000 but are useless for input greater than 1 million. Linear time and n log n always remain practical for 1 billion items. And log n also is the boss. Nothing is better than that. You don't have to memorize this table. I just wanted to show you how much different does it makes, how important is time complexity. In my next video, I'll teach you all the rules and methods to calculate time complexity. I'll take lots of examples, plus we'll calculate time complexity of bubble sort, selection sort and insertion sort. Thank you so much for watching this video. That's it guys. I hope you enjoyed this video. Please do comment. I really like to read your comments, and please support Code Archery by liking this video.